Hi, I'm Prithak and today I'll be presenting the execution of our project of prototype of car monitoring parking system. It is a module of smart parking system. In this project, through this project, we can actually know in real time whether the slots that are being indicated over here, which are pointed by infrared sensors, there are 6 infrared sensors, we can know in real time whether the car is being present in the slot or not. This project was done by Bijan, Anurag, Pratik, Sandesh and myself, Prithak. This is the module of smart parking system. For the execution of this project, we've used Arduino, Node MCU 8266 Wi-Fi module, 6 infrared sensors, some connecting wires, breadboard, and some female headers. In the context of softwares and programming languages that we've used to implement this project, the desktop application that you are currently seeing in your screen was made by Visual Basic Programming Language and its .NET framework. It's a form-based desktop application that is being run through Visual Studio. Of course, we've used Arduino IDE for the programming of Arduino and Node MCU 8266 Wi-Fi module, and we've used Blink application for the framework of our app and the cloud-based system through which we'll get real-time data of whether the slots are being filled by a car or not. So let's go ahead. Before showing you the execution of this project, firstly I would like to show how the hardware is being assembled. So as you can see, we've used 6 infrared sensors. We've named each slot 1, slot 2 and slot 3 with the variation in red and green sketch pens. Now the connection is done like this. The out pin of each infrared sensors is being connected with the ports of 4, 5, 6, 7, 8 and 9, and then the ground pin of the infrared sensors are being mixed over here and are being connected in the ground slot of the Arduino. The VCC pin of the infrared sensor are being mixed over here, are being all of them are being like connected in a junction over there and are being connected to the VCC port of our Arduino. So that was the basic connection, and then we've used a USB USB cable of our laptop to connect the Arduino and to power the Arduino to send the code. Furthermore, we've connected slot 2 and 3 of the Arduino to the slots of RX and TX, that is the receiving and transmitting ends of the Node MCU Wi-Fi module, and then we've also connected the ground pin of the Node MCU module to the ground pin of the Arduino, and furthermore we've used data cable, USB data cable, to connect and to send the codes of our Arduino IDE to Node MCU Wi-Fi module. Now let me show you the desktop application of our project. It is a framework obviously and is being run by Visual Studio. We've not published this anywhere, but since the entire project is a prototype, we can publish this in a certain website, and we can host the website or we can host the desktop app itself. The screen, as you can see, parking 1 and parking 2, we've used parking 1 as the slot 1, slot 2 and slot 3. They are being indicated by red sketch pens over here, so they are parking 1, lot 1, and then we've used parking 2 as the parking lot 2, and slot 1, slot 2 and slot 3 are being indicated by the green sketch pens slots over here. Now the toolbar that you're seeing above is the status of whether the slots are filled or not. As you can see, in a blink of a second, we can actually get the value 0 or 255 if it is filled, if the slots are filled, and then in the text box over here, the data are being taken by its slots respectively. Now as you can see in the check boxes, slot 1, slot 2, slot 3 of both the parking slots, none of them are ticked right now. So if I put a car in one of the slots, so this is parking 1, slot 2. So what should happen is, due to serial communication, the parking 1 of slot 2 should be ticked. Parking 2, none of them are ticked. and parking 1 of slot 2 are ticked. Now let me just move the car to slot 3. Now let's see what happens. See, parking 1 of slot 3 is being ticked. Now let me get another car. Apologies for the fact that I don't actually have a car. I've got an helicopter, but it works the same because we're just checking whether the sensor works. So now parking 1 of slot 2 and parking 1 of slot 3 should be ticked, and it is ticked over here. So now let me just move around and play around over here. Let's go from parking 2 slot 2. So parking 2 slot 2 is ticked, and since we've not moved our helicopter from parking 1 slot 1, it is also being ticked. Now let me just move my helicopter from parking 1 slot 2 to parking 2 slot 1. Now parking 2 slot 1 is being ticked, parking 1 is being emptied. And as you can see, the data are being transferred. The 255 indicates parking 1 slot 2, and over here you can see all of them are off, but the second slot 1 and second slot 2 are only on. So this was the desktop framework application of our project. Now for the mobile application framework, we've used Blink application for the purpose of the cloud server purposes and for the framework of our app. So as you can see over here, parking 2 of slot 1 and parking 2 of slot 2 are filled, and you can see in our desktop application as well. So over here, now if we hit the play button, so note that if the Wi-Fi chip was not connected, it would have shown 1 or something or error sign over here, but it didn't, so which means that our node MCU Wi-Fi module is connected. This is parking 1. So let's go to parking 2. It is showing that the slot 2 of the respective slots are being connected. Now let me just move around the vehicles. I want to keep this over here. The LED just blinked, which means that the sensor is sensing, and I want to keep this over here. So it's showing tick over here, and then it shows tick over here too. Now moving around the vehicles, I don't even know if helicopters are called vehicles, but here we are. Yeah, so over here, so if we check the desktop app, it's working fine, and then if you check the Blink app, it's working fine, hopefully. Yeah, it is working fine. Now if we have to like move around the vehicles again, like, yeah, now if we have to move around the helicopter over here, yeah, it's switched, and since we didn't change the position of this car, it's still red. So this is the execution of our project. We all of us have had really fun time doing this project. It was a great learning experience, and hopefully you enjoyed it.